So notes number 2 from Unit 8 is all about simplifying a square root into simplest radical form. Very fancy terminology there, but don't be intimidated by the words. As always, vocabulary will be helpful, but if we just know the process, sometimes the process is a lot simpler than just the vocab that you have to use to get there. So let's just talk about square roots, also known as radicals. Okay, so a square root is a radical. And you need to be able to make a list of perfect squares, because if we can see these, we can easily take the square roots of them. So like square root of 1, the square of 1 is 1, and 2 squared is 4. And again, the number that I'm writing is the number that we really want to focus on, because that's the number that we can take the square root of. 3 times 3 is 9, 4 squared is 16, 5 squared is 25. 6 times 6 is 36. 7 times 7 is 49. How'd you do so far? Those ones, hopefully you were able to do without the use of a calculator. And then we do 8 squared. 8 times 8, 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11, these ones get a little trickier. 121. 12 times 12 is 144. Excellent. Okay, so I don't think we'll have to actually go above 100 today, but just in case you know how to find the perfect square, it's when you square a number. So we'll be looking for those, and that's why they're at the top of your notes today. Those are going to be very important. Also important is a couple of concepts. And one concept is to know that there's 2 possible answers for a square root. So can you think of 2 integers that could be used for x to make this true? If I have x in parentheses and square it, what 2 numbers would be equal to 25? Because 5 times 5 is 25, or we could have a negative 5. Because remember, if I put this in the parentheses, it is negative 5 squared. And a negative times a negative is in fact a positive. So there you have it. Both of those values, both of those numbers could be equal to positive 25, and therefore we consider them both answers. So this means that the square root of 25 could be both positive 5 or negative 5. And you're going to find that we write this today instead of as 2 numbers, but as 1 5 with a plus and a minus in front. So you're going to have to get used to seeing that as a way to write both answers, both the positive 5 and the negative 5. Okay? The heat's on, and it's also inside of my mask. Whew, it is warm. Next up, number 3, we can also multiply these before finding the square root. So this is a skill from last class, and some of us had a little trouble on this, so I want to make sure you go back and look at that. I don't want to find the square root of 2 because on its own, it's an irrational number. It's a never-ending, never-repeating decimal. Same with the square root of 8. So you're not going to get very far if you do the square root of those numbers first. But we can multiply them together first, and we'd get 16. Okay? Not the time to participate right now, okay? I'll let you know. But that's good. That's good. So the square root of 16 can be found because, again, that comes from our list of perfect squares, and that's right here. So if we're thinking about numbers that are really important today, again, always go back and refer to this list. So we do the square root of 16, which is 4. 4 times 4. But now we have to think of it as either positive or negative 4. That did that for us. Okay? Let's keep it going here. And again, the square root of 12, irrational. So we don't want to do that first, nor do we want to do the square root of 3. Instead, let's think about multiplying those numbers together, which is a legal mathematical thing to do. Just believe me when I say that. You're not breaking the law. Now, who can think of a number that would multiply to 30? See a positive 6. 6 times 6 is 36, or a negative 6. So that negative 6 times negative 6 is actually 36. So 2 different possibilities there. Let me get the chat going here just in case anybody wants to start participating with us in the chat. Okay. Next up, again, the square root of 20 and the square root of 5. We don't like either of those because they're irrational. So we multiply 20 times 5 first, and that will make 100. And is 100 a perfect square? 10 times 10, right? So the square root of 10, or square root of 100 is really 10. And so this could be either a positive 10 or a negative 10. So we write both because we're not exactly sure which it is. Okay? But hey, some of us will be coming back after spring break, which is going to be awesome to see you guys. So for exercise number 4, we're going to write the following square roots in simplest radical form. Again, radicals are just another way to say square roots, by splitting them into 2 parts. And hopefully one of the numbers that we're going to split it up into is a perfect square. And we want to try to find the largest perfect square so that we can take the square root of that number. So let's start with something simple like 8. Remember that factor list that we were making for factoring? That's going to come in handy here because it's going to let us see the ways that we can rewrite 8. So 1 times 8, 2 times 4, 3, no, 4 times 2, and again, I'm repeating myself. So out of those factors, do you see a perfect square? Hopefully you see the 4, right? That is a perfect square. So we need to take these 2 numbers and rewrite 8. And always write the perfect square first. So the square root of 4 times the square root of 2. Now this is no different than what I just showed you in how we can take 2 square roots and make it 1. Now we're taking 1 square root and making it 2. And we're going to do that for our benefit because the benefit is we can complete this process. We can find the square root of 4 to be 2, and that could be a positive or a negative 2. But then I still have the square root of 2, and that would be your answer. A real 2 outside of the square root, like we would always see in everyday life, and then the square root of 2, and that's it. We leave it in square root form because, again, this is going to be a never-ending, never-repeating decimal. Much easier to write it like that. Hopefully got the hang of it, and let's keep practicing that with 45. So 45, hopefully that's a number that we can factor pretty easily. 1 times 45, again, just different ways to write 45 as a multiplication problem. 2 doesn't go into 5, so we go to 3 and 15. Again, that's not going to work. 4 doesn't go into 45, but 5 does. 5 times 9, and we can stop right there because I see a perfect square. Do you see it? It's the 9, right? So 5 times 9. Now let's instead write that as the square root of 9 times the square root of 5. I want to put that perfect square up front. And what I mean by that is I want to put this one first because that's the one that I can take the square root of. So the square root of 9 we know is 3. Now we know that it could be positive or negative 3. And then I have to bring along the square root of 5. Okay? Easiest, cleanest way you can write that answer. So if you're not really great with your multiplication facts, the calculator can be there to help you. So go ahead and let's pull it up. And remember how to make a factor list? We can press the y equals, and we can put in the number that we're trying to factor. In this case, it's 48. We're then going to divide it by the variable key. So 48 divided by x. And then, if we go to the table, it will create a list of factors for us. So second and graph. Now, we're not going to look at anything that's negative, so let's just look to the positives. And I'm going to scroll down here till I get to, the ones that I want to try to work with. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6, 6 and 8. Which one of those factors do you see a perfect square in? See a perfect square out of any of those? 48 is not a perfect square. Anybody there at home see one of those numbers as a perfect square? One of the ones that you get by taking the number and squaring it.
So what do I press second and trace?
We'll do that next time. We'll get you caught up next time, Andrew. But for right now, just kind of take a look at the list and see if you can pull out the perfect square. Yep, you can look at them here too. No? Okay. Well, 48 is not a perfect square, nor is 24, but the 16 is. So we can rewrite the square root of 48, and I want to rewrite the square root that has the perfect square in it first. So 16 times the square root of 3. And so these are still in the square root because we haven't done the square root yet. We've just rewritten it. Now we're going to do the square root. The square root of 16, like we said, is 4. That's why we chose to use 16. And it could be a positive or a negative 4. And then we still have the square root of 3. Okay? I'll complete that process with you one more time using the calculator for letter D. All right, so back to the calculator and back to y equals. Let's remove the 48 and put in 75. So 75 divided by x. We can keep that part. So now that that's in the calculator, we can generate a list of factors by going to the table. So second and graph. And again, starting at 0, let's work down the page, and we're trying to find the biggest perfect square. So looking at the y values, I got 75, nope, 37.5, no decimals are perfect squares. 25, there it is. So 3 and 25 would be our two factors that we would want to use. Now, new thing here, we have a negative. So think of that as a -1, and we'll talk about that in just a moment. But right now, let's break this up into the square root of 25 times the square root of 3. Again, 25 times 3 is 75. Now I bring down the -1. Now I do the square root. So I'm going to do the square root of 25 as a positive or -5. And then that's going to have to go in parentheses. And then I have the square root of 3. I'm running out of room here with my beautiful little background screen. So let's see if I can use the magic grabby hand here. All right, perfect. And now I would do a little bit of multiplication here. Whoops, let's go back to the pen. So I'm going to multiply a negative times a positive 5. Well, that's going to be a -5. And I'm going to multiply a negative times a negative. Well, that's going to be, again, a positive 5. So I still have one positive and one negative, even though I have this -1 here. So at this point, it didn't change. I wanted to use the -1 here to show you that a negative times a positive is still the negative, and a negative times a negative still gives us the positive. So that's going to have to stay there. Okay? Next up is 72. So I go right to the calculator because I don't really feel like trying to factor that. I go y equals. I have 75 in. Let's change it to 72. I press second graph. And I see all the factors of 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12. Did I say a perfect square? Did you hear it? Did you recognize it? The 36, right? So I rewrite this as 5, because there's a 5 out there. And then I got to think of this as the square root of 36. I always want to put the perfect square first, and the square root of 2. Another way to write 72. I then do the square root of 36 because I actually can do that without the help of a calculator. I know that it's 6 times 6, but it's a positive times a negative. And I put this in parentheses. It's out of the square root. Then I do the square root of 2. Next, I want to go ahead and multiply this part right here. Now that's 5 times 6 and 5 times -6. So that positive negative is not going to change, but 5 times 6 we know as 30. And we can multiply these numbers because they're outside of the square root. They're like regular old, everyday kind of numbers that we deal with. Bring along the square root of 2, and you are done. Okay?